So I'm just going to talk to you about graphs. In some of your papers you will have had to do a graph. So every graph needs a title, or in the mark schemes it will be called a caption. And in the title you have to link the independent variable, that's the thing that is on the x-axis, with the dependent variable, that's the thing that is on the y-axis. And if biological material has been used, you have to name the biological material. So a title could be a graph to show how the rate of reaction changes with temperature when potato catalase is added to hydrogen peroxide. The dependent variable, that is the result, the thing that you record, is on the y-axis. The independent variable, that is the one thing that you change every time you repeat the experiment, that is on the x-axis. And when you're doing a graph, be very aware that you have to use most of the graph paper. So when you have plotted your points, rule straight lines between the points, but you have to be very precise with that. The ruler has to go into the middle of the point. You see your labels, make sure that they have the axes. You have named the variable, then you put in a solidus, and then you write the very specific unit. So it might be temperature off, and you need to say what it is the temperature of. So the temperature of the catalase and hydrogen peroxide solution / degrees C. For example, it might be percentage starch remaining, and that could be the solidus, and then it is percentage. Sometimes from graphs you have to calculate the rate, so you've drawn the graph and then you have to calculate the rate, and that will be the oxygen produced, so that would be the dependent variable divided by the time that was taken to produce that oxygen. If I was trying to work out rate from this graph, I would just draw on a triangle. I'm sure you've done this in maths. And then it would be the oxygen produced, which would be, sorry for my wobbly writing here. So the oxygen produced, you would take this value from this value, and that would give you the oxygen produced. And then you divide it by the time that it took to produce that oxygen, which would be this value, and then you take this value from it, and that would give you the time. So the rate would be this value divided by this value. Sometimes it's a little bit tricky to know what type of graph you need to draw. So over here we have a line graph. So when would you draw that? It's usually when the independent variable, the one on the x-axis, and the dependent variable are both numbers, and it's when a change in one usually causes a change in the other. So that is when you would draw a line graph. So then when would you draw a bar chart? Now you draw a bar chart whenever the independent variable, so the one down here, is actually a category and the dependent variable is a number. So for example, in the class you might have people with blue eyes and people with brown eyes. That's a category, that's words down here, not numbers, and in that case you would draw a bar chart. Remember that a bar chart has spaces between the bars, and every bar should have the same width. A histogram is different. A histogram is where the bar charts the bars actually touch, and you might have numbers on the x-axis. Now there is another type of graph which is a scattergram, and here we have a scattergram. And that's where the independent variable and the dependent variable are numbers, but you don't know if one is related to the other, and that is why you draw a scattergram. Now you can then draw through the scattergram a line of best fit, that is okay. And in this scattergram you could see that as this variable here increases, this variable here will increase. So it allows you just to establish, is there a relationship between those two factors? So just A few pointers then about tables. You can get a lot of marks from tables. Every table needs to have a title. It's just like the title in a graph. It should link the independent and dependent variable, a table to show how. Remember that the table should begin with a capital letter. That's really important. And the first column of a table should be the independent variable, and then the other columns in the table are the dependent variable. Here's just an example. So the independent variable here is temperature, solidus, degrees C, capital letters, really important. And then over here we have an example of a dependent variable, time taken for starch to disappear / s for seconds. Remember, you see these units, they should always be at the top and they should never be in the body of the table. Sometimes using a table you might be asked to do a calculation. So you might be asked to calculate the rate of juice production in the first 3 minutes. So you would look at the table and it would give you the amount of juice that was produced, and over here you could see the time in so many minutes. So to work out the juice production, it would be the amount of juice collected in 3 minutes divided by 3, which would be the 3 minutes, and that would be cubic centimetres min to the -1. The last thing I want to mention then is drawing block diagrams. Now the line quality in your block diagrams is really important. You must not draw individual cells if they say it is a block diagram, and it's really, really important to put in all of the labels that you know. So if I was doing a block diagram for this strange structure here, here I have the top layer, and then I have this middle layer that is kind of this shape. Now the proportions are really important as well. Then I have this layer, it's maybe a little bit thicker, and it goes like this. And then I have the bottom layer. Now this is far from perfect, but if you look at my block diagram here, this top bit represents this top bit. The line quality is okay, but you might lose a mark there or you might lose a mark there. It's a bit raggedy. This layer, it's okay, it represents that layer. This layer represents that one, and if you just look, it's obvious that that blip belonged to the bottom layer, so I put it in the bottom layer, and this is roughly the same shape as this. Now, block diagrams don't look very dramatic. Make sure you know the layers of leaves and the layers of the ilium. Those are very popular for block diagrams. So just divide the drawing that you see into layers, then get the proportions neat, get the line quality good, and then add in your labels.